Welcome back, everybody. Ready for another deep dive? Today, we're tackling a tough one. As a senior architect, you're probably wrestling with this all the time: how to design production ML pipelines that can actually keep up with the real world. And that's where continual learning comes in, right? Exactly. Continual learning is a hot topic, but there is a lot of hype out there. I want to cut through that and get to the practical stuff. What are the real trade offs? What are the potential pitfalls when you're trying to build systems that can actually learn and adapt on the fly? It's one thing to talk about continual learning in theory, but when it comes to production, that's a whole different ballgame. Robustness, reliability, it's got to work in the real world. So, why is continual learning such a big deal anyway? I mean, the traditional approach, train your model, deploy it, and call it a day, has worked pretty well for a lot of applications, right? Sure, it's been the go to for a long time, but here's the catch: the world just doesn't sit still. Data changes, things evolve. You train your model on a snapshot of data, but then user behavior shifts, new trends pop up. Even the very definition of what you're trying to predict can change. And that's where that nasty data distribution shift comes in, right? Your model is stuck in the past, making decisions based on data that's no longer relevant. Think about it like this: you've got a model predicting customer churn, trained on last year's data. It works great until a sudden economic downturn hits. Suddenly, churn rates are through the roof, but your model's blind to it. It's still looking for signals from a different reality, and its predictions become less and less accurate. That's where continual learning comes in. It aims to keep your models in the loop, constantly adapting to new data and feedback. So it's not just about building a model, it's about building a system that can learn and adapt on the fly. We're starting to see some really cool real world examples of continual learning in action. Have you ever wondered how TikTok manages to keep you glued to your phone for hours? Okay, maybe we don't want to dive into the ethics of social media addiction, but I've always wondered how they seem to know exactly what I'm going to be interested in next. Continual learning plays a big role there. They're constantly fine tuning their recommendation algorithms in real time. Every comment, every second you spend watching a video, it all feeds back into the model, shaping your feed. It's like the model's got its finger on the pulse of your ever changing tastes. And it's not just TikTok. Think about music streaming services. They use continual learning to refine your recommendations by adding new artists and keeping things fresh based on your listening habits. It's like having a DJ in your pocket who learns your preferences and grows with you. Pretty cool, right? But I imagine building these kinds of systems comes with its own set of challenges, right? Where do you even begin? Well, one of the big ones is data. These models are hungry for fresh label data. In traditional ML, we used to batch training on static data sets, but with continual learning, it's all about a constant stream of new information. So you need a pipeline that can handle that. You need to integrate with real time data sources, maybe using technologies like Kafka or message queues. You also need to figure out how to extract labels quickly, maybe from user interactions or other feedback mechanisms. It's all about building infrastructure that can handle the constant flow of data efficiently and reliably. And then there's the question of how often to update the model, right? Update too often and you risk overfitting to noise in the data and wasting resources. But if you update too infrequently, you lose the benefits of adapting to change. So, how do you find that sweet spot? That's the $1 million question. It really depends on the application. You need to think about the value of data freshness. How much does having the latest data actually improve model performance? Companies like Facebook have done a lot of research on this, and they've found that even small increases in data freshness can lead to big performance gains, especially in dynamic user facing applications like ad prediction. So it's not just about having fresh data, it's about having the right kind of fresh data, data that actually moves the needle. Then there is the whole monitoring aspect. You need to be able to detect when those data distribution shifts are happening. When the data your model is seeing in production starts to diverge significantly from what it was trained on, that's a big red flag. It might be time for an update. So it's not just a set it and forget it thing. You have to keep an eye on things and make sure the model's still on track. It's an art, really, finding the right balance between being reactive and proactive. But with the right tools and techniques, you can build a system that adapts and evolves as the world changes around it. And that's what continual learning is all about, right? Exactly, building systems that can learn and adapt just like we do. So, we've talked about why continual learning is important and some of the high level challenges, but what are some specific techniques and tools we can use to implement this in production? Well, let's dive into that. With continual learning, testing is a whole different ball game. With traditional ML, we kind of front load a lot of the testing, but with continual learning, you're in a constant state of evaluation. It's like the testing never really ends. Exactly, because you're always pushing out model updates. You need to be confident that those updates are actually making things better, not worse, right? A small error in a live system can snowball quickly. So, how do we avoid that? What are some strategies to test these evolving models? A/B testing is a big one. So it's not just about testing the new model before deploying it. You are constantly running live experiments to see which version of the model performs best. You deploy the updated model alongside the existing one and route a small percentage of traffic to the new version. You are running a side by side comparison in real time. Track the metrics and decide if it's time to roll out the update to everyone. That makes sense. A/B testing becomes even more crucial with continual learning. Are there other techniques to manage these live updates? Canary deployment is another helpful one. It's about dipping your toes in the water before you dive in. You roll out the update to a small subset of users or servers and monitor it closely to make sure everything runs smoothly before scaling it across the system. It's a great way to limit risk if something goes wrong. Exactly, you're containing the risk. So, how do we know when an update is bad? What should we be looking for? Monitoring, monitoring, monitoring. You can never have enough monitoring with continual learning. You need to track a wide range of metrics, not just overall accuracy, but also things like latency, resource consumption, and specific types of errors. These metrics give you clues that something's off so you can catch issues before they become major problems. And manually tracking all those metrics sounds like a full time job. Are there any tools that can help automate the process? Absolutely. There are great platforms designed to monitor ML models in production. They track a wide range of metrics, set up alerts, and even provide insights into why performance might be changing. These tools help take the burden off your data scientists and engineers, letting them focus on improving models instead of babysitting them. So we've got A/B testing, Canary deployment, and monitoring tools. Those are some key pieces of the puzzle. But what else should we consider in a continual learning environment? Data drift is a big one. Data drift happens when the data your model sees in production starts to differ from the data it was trained on. It's crucial to detect data drift early on. Tools can alert you when drift happens, acting like an early warning system. Once you know there's drift, you can start addressing it, maybe by retraining your model with more up to date data or adjusting its parameters. Exactly. Adaptability is key. Continual learning is a continuous process, not a one time thing. It's all about evolving, keeping your models fresh, and staying relevant. This is starting to paint a very different picture of ML development, isn't it? It's not just about building a model and deploying it. It's about constantly monitoring, evaluating, and adapting. It's a whole new paradigm, and it's a lot more complex. But with the right tools and techniques and a mindset of continuous improvement, we can build systems that thrive in a constantly changing world. Thank you for watching. If you found this video useful, don't forget to like, subscribe, and share.